Okay, so today we are talking about multiplying polynomials. Now, we've talked a lot about polynomials already, but just as a reminder, your polynomials can have numbers and variables and letters, and it can have exponents, but the exponents on the variable have to be whole numbers. And remember, a whole number are those counting numbers including zero. We've talked about the number system as well. So if you have an exponent with one of the letters, it has to be a whole number. So let's talk about some things that are not polynomials. Things that are not polynomials, if your variable is under a radical, that's not a polynomial. If your variable has an exponent that's not a whole number, in other words, if it's a negative number or a fractional number, those are not polynomials. If you have a variable in the bottom of a fraction in the denominator, that's not going to be a polynomial. And if you happen to have an exponent that is a variable, it's not a polynomial. But for today, we're only dealing with polynomials. And when you multiply a polynomial times a polynomial, your answer will always be a polynomial. So if you get anything else, that means you've made a mistake. So let's go ahead and talk about multiplying. Earlier this week, you talked about the distributive property. I'm going to make this bigger. So let's look at distributing here. We're going to take everything from this first polynomial and multiply it by everything in the second polynomial. There are two terms in this first polynomial, right? It's a binomial. So we need to take the first term, which is r, and multiply it to each term of the second, which is a trinomial. So we got to multiply it 3 times. I'm going to go ahead and write that out so I don't forget what I'm doing. So r times r squared. And then I have r times negative 2r. And then I have r times 3. But that's not all we have to do because this is a binomial. We've completely left out negative 1. It also is a term and it also has to be distributed. So now I'm going to take this second term and I'm going to distribute it to everything in the back parentheses. So I have negative 1 times r squared. And then I have negative 1 times negative 2r. And then I have negative 1 times 3. All right, so that's how we're going to distribute here. We're going to take every term in the first parentheses and make sure we multiply it by every term in the second parentheses. All right, so let's multiply it out. R times r squared. Remember, this is 1r, right? If we don't see an exponent, it's understood to be 1. And r squared represents r times r. That's what it means to squared, is you multiply it by itself twice. So if we write this all the way out, this is really r to the third power. Now, I'm not going to write that out every time. I just wanted you to see where that's coming from. But remember, our rule of exponents says when you multiply with the same base, you add those exponents. So the base is going to stay the same, and you're going to add those exponents. All right, let's look at this second term. We have r times negative 2r. So we multiply numbers times numbers and letters times letter. There's no other number here except for negative 2, so I'm going to go ahead and write that down. But I do need to do my r times r. And it looks weird to leave it as rr. That would be the same thing as r squared. Remember, there's an exponent of 1 here and an exponent of 1 there. So you keep the base the same and add the exponents. For this one, we have r times 3. We're just going to write that out, 3r. But it looks really weird to not have a sign here. So since this is a positive number, we're going to put a plus sign to show that that is a positive 3r. All right here, we have negative 1 times r squared. So that would just be negative 1r squared. Here we have negative 1 times negative 2r. A negative 1 times a negative 2 becomes a positive 2, and then we got to put that r on it. And then we have negative 1 times 3, which is a negative 3. That is some beautiful multiplying, but we are still not done. Now we have to go back and combine our like terms. So I'm going to start with the highest exponent. In this case, it would be r to the third. So I'm going to look and I'm going to say, are there any other r to the third powers? And the answer is no. So I'm going to go ahead and write that one down. Then I'm going to look at my next highest exponent, which is r squared. And I'm looking for other r squareds, which it looks like is right here. Negative 2r squared minus 1r squared. That would be a negative 3. r squared. Now remember, this is kind of tricky because you're like, wait a minute, up here you changed the exponent and down here you didn't change the exponent. That's the difference in adding and multiplying. When you multiply with the same base, you add the exponent. But when you're combining like terms, when you're just adding them, that term stays the same. The exponent stays the same. We're just saying, well, how many r squareds do we have? We have -1 and -2, so that makes -3r squareds. All right, I'm not done combining like terms. Now I'm looking at my r's. I have 3 r's and 2 r's, which make 5 r's. And then I got my constant over here hanging out by himself. My constant is a -3. So this is my final answer. Now I did put it from highest exponent down to lowest exponent because that is standard form. So that's what I did. If you do it a different way, it doesn't mean it's wrong. It's just probably not what the answer is going to look like if it was a multiple choice test. All right, if we have time, I'll come back and I'll show you box multiplying on this one. But for now, I'm going to move over here to this problem. Oh, and I wanted to mention one other thing here. This was a polynomial times a polynomial. And if you look at your answer, it is still a polynomial. That's good. We're going to come back to that. All right, over here we have a polynomial. This is a binomial times another polynomial, which is a binomial. So when we multiply here in the tabular method or in the box method, we have to build a box the right size. Since this is a binomial, since there's 2 terms, I'm going to need, and this one's also 2 terms, I'm going to need a 2 by 2 box. If we had box multiplied over here, you have 2 by 3. So your box would have looked a little bit different over here because you would have had 2 terms by 3 terms. So you got to build the box whatever size you need, right, based on the number of terms. And then I'm going to go ahead and put my values on top of the box. So my first term here is x times y. My second one is a -2. Here my first term is x squared, and this is a +1. And now I am going to multiply each place inside the box. So I'm going to do x squared times x times y. So let me just write this out tiny up here. X squared times x. Oh gosh, that's messy. That's 3 total x's, right? If you have x squared and another x, that would become x to the 3rd. You know what? This is too small. I'm losing my mind here. I'm not going to squish it up there. X squared times x is x to the 3rd, and then there's just 1 y, so we're just going to leave that 1 y there. X squared times -2 would give us -2x squared. 1 times anything would just be itself, so 1 times xy is just xy. And 1 times -2 is going to be -2. Now, when we go to combine our like terms here, we have x to the 3rd power times y. I don't see anything else that has those same exponents, so I'm going to go ahead and write that one down. And then I see -2x squared. There's no other x squareds to combine it with, so I'm going to go ahead and write that down. This is x times y. There's no other xy's to combine it with, so I'm going to go ahead and write that down. But again, this looks really weird, right? You can't leave no sign here, so since it's positive, put that plus sign. And then we have our constant, and there's no other constants to combine, so that would be it. We had a polynomial times a polynomial, and it is still, the answer is still a polynomial. Beautiful. So let's talk a little bit more about what it means to be a closed system under multiplication. So for it to be a closed system under multiplication, it means you have to have one type times the same type equals the same type. I know I said type, that's confusing, but here we're dealing with polynomials, but sometimes they're asking about rational numbers or irrational numbers. But in this case, they want to know if you multiply a polynomial times a polynomial, for it to be closed, it has to always equal a polynomial, which it does. It says, which of the following shows this? Well, in option 1, this isn't even a polynomial because the variable is in the denominator of a fraction. So that's not even a polynomial. I don't even want to deal with that one because it's not even a polynomial. In option 2, both sides are polynomials, so I'm not going to mark it out yet. In option 3, I see some exponents, but that's a whole number. Yep, everything's good here. This is a polynomial. Option 4, you have x raised to a fraction. That's not okay. And you have x under a radical. That's not okay. Well, I mean, it's okay. It just means it's not a polynomial. So I'm going to immediately mark out option 1 and 4 because they're not polynomials. And we're trying to show it's a closed system for polynomials, right? So then we're looking at option 2 and option 3. In option 2, let's see what they're doing here. They're taking 5x plus 3x, that does equal 8x, yeah. And they're taking 1 plus 6, and that equals 7. But they're combining like terms here. This is an addition problem, right? They're adding. So this is showing that it's closed under addition. That's not what it's asking us to do. It's asking us to show that it's a closed system under multiplication. So this is the one where it takes a polynomial times a polynomial and it equals a polynomial. This is going to be the one that shows that it is a closed system under multiplication for polynomials. Let me see. Oh, I got 4 minutes left. I'm going to go back and I'm going to show how to box multiply on this one. Let's just see if I have enough time. I don't know. It'll be a race against the clock. Can she do it? Mission impossible. Okay, so I have r and -1 on this side. And then I have r squared, -2r, and 3. Now, it doesn't matter. When you build your box, you could have done a 2 by 3 vertical too. It's going to be the same thing, right? This one happens to be horizontal. Could have been vertical. Doesn't matter. So we have 1r here and 2 r's there. When we multiply, that's going to be r to the 3rd power. We have an r times a -2r. So the -2, and then we have an r here and an r there. That's going to be r to the 2nd power. R times 3 would be 3r. -1 times r squared would be -1r squared. -1 times -2r would be a positive 2r. And then a -1 times 3 would be a -3. And now some people like to write every single term out. I actually like to combine my like terms within this and just write my final answer. So let me show you what I mean by that. I see my r to the 3rd power here. I'm looking for any other terms that have r to the 3rd power. There aren't any, so I'm going to go ahead and write that one down. And then the next thing I notice is I have an r squared. I have another r squared. So before I even write them down, I'm going to go ahead and combine those. -2r squared minus 1r squared would be -3r squared. And when I'm combining here, I'm adding and subtracting. I'm done multiplying. Once I filled out the box, I'm done multiplying. All right, next I see a 3r, and I have another. I have a 2r, so 3r plus 2r is 5r. I'm going to put that plus sign in front of it since it's positive. And then the last lonely little thing here is our constant. Notice when you distribute it, you will get the exact same method as when you box multiply, right? It's just 2 different ways to do the exact same thing. You pick your favorite method and you stick with it. If you love distributing, go for it. If you love box multiplying, go for it. There's no right or wrong way to do it as long as you get the correct answer. All right, that's it for this video. Bye, y'all.